So this one is just the, this is just our limit notation basically here for an integral. So normally we've got the limit as n approaches infinity of the sum from k equals 1 to n of f of x sub k times delta x is what we're normally looking at, like when we do this limit notation, where delta x is, well, I'll write this over off the side. Delta x, remember, is always b minus a over n, and x sub k is always equal to a plus k delta x. And so really then what we're looking at is a limit as n approaches infinity. Our delta x is b minus a over n, so that's this 1 over n. So b minus a needs to equal 1. So if we look, that eliminates choice C. And then our x sub k is a plus k delta x. And so f of x sub k ought to be, it's either 1 over x or 1 over 2 plus x. 1 over x would just look like 1 over k delta x. Whereas we do not have that. We have 2 plus k delta x. Sorry, 1 over a plus k delta x. So we have 1 over 2 plus a plus k delta x. So it couldn't be this one. So that just leaves us with these two. And since we have a 2 down here, this is our 2 plus x. Our f of x sub k ends up just being a plus k delta x, which means that a needs to equal 0, so that k delta x can just be k over n, which is what we've got here. So we've got 2 plus k over n, 2 plus the next k over n, 2 plus the next k over n, all the way up until the last one. If we had this one, we'd still have the 1 over n, but we'd have to have 2 plus k delta x. So we'd have a 4 plus k delta x if it was going to be choice D. Does that make sense or no?
Yeah, that makes sense.
Yeah, it sort of looks like they want you to deal with it like a series or something, but that's not actually what they're looking at here. Other questions?
Uh, 19.
19. All right. Okay, so for number 19, they've got our series here, the sum from n equals 1 to infinity of negative 1 to the n times n over n squared plus 1. Which of these is true? So first off, taking a look at the first one, direct comparison with 1 over n. Well, this series here, negative 1 to the n times n over n squared plus 1. This one alternates, and so direct comparison with something that doesn't alternate is not going to work, so we can immediately eliminate choice A. Let's see here. Makes more sense to think about choice D. If we think about choice D, I mean, we can sort of just stop looking. Well, we can really not even bother to look at C, because talking about comparison with 1 over n squared, this is n over n squared, so really that is more like a 1 over n. So it would either be limit comparison with 1 over n or by the alternating series test. And so you could do the limit comparison with 1 over n if you wanted to, or we could just look at the alternating series test. This does alternate, right? For all positive values of n, this is going to alternate back and forth. And the terms are definitely decreasing, right? Because this is an n over an n squared plus 1. So as n gets larger, this is going to become, when n is 2, this is going to be a 2 over 5, and then it's going to become a 3 over 10, and so on. It's going to, the coefficient there, or the value of it's going to keep getting smaller regardless of the absolute value. And it's going to go towards 0 because the limit is n approaches infinity of n over n squared plus 1 is 0. So we should be able to say that it converges by the alternating series test. Good or no?
Yeah, easier than I made it out to be.
Yeah. That's all right. Yeah, and if one of the answer choices is converges by alternating series test and you have an alternating series, go in, I mean, immediately I'd go in and test and make sure that they're decreasing and it's going towards 0. And if it is, then you're already done. You don't need to worry about anything else that's written. Other questions?
$26.
26. Just to let you all know, Sean's not the only one that's allowed to ask questions. If any of you all, other people in the Zoom, want to ask questions, you can ask also. You were all aware of that, right? Okay. Which of the following series are conditionally convergent? So if we take a look at choice 1, it definitely converges, right? -1 to the n over n factorial. But if we were to take the absolute value of this, this would then become just 1 over n factorial. And 1 over n factorial is just the series for e to the x evaluated at x equals 0. And that should also converge. So this also converges. So we can immediately eliminate anything that has a 1 in it. Right? At that point, we can sort of not even bother to look at number 2 because they both include number 2. Right? So we should know that 2 converges conditionally. And then for number 3, we have -1 to the n over n plus 2, which converges by the alternating series test. But if I were to take the absolute value of that 1 over n plus 2, that diverges by the p-series test. So this is also conditionally convergent. So it must be choice 3. One with 2 and 3. Good or no?
Yeah, I'm good with that one though.
Okay. Cool. Other questions? Number 15. All right, number 15 here. We got an integral from 1 to infinity of this, so we'll rewrite this as a limit as a approaches infinity of an integral from 1 to a of 6 times x plus 3 to the -3 halves dx. And then this becomes the limit as a approaches infinity, and we'll integrate this. So the integral of 6 times x plus 3 to the -3 halves. The x plus 3 is our u, so we don't, I mean, it's just a regular power rule anyway. go up to the negative, from -3/2 to -1/2, and then divide by -1/2, which is going to make this a -12. And that's times x plus 3 to the -1/2. And that's going to go from 1 to a still. So we got the limit as a approaches infinity of -12 times a plus, let's write it this way, -12 times 1 over the square root of a plus 3 minus 1 over the square root of 1 plus 3. And that's going to give us, as a goes towards infinity, that first piece is going to become 0. So we're going to have -12 over, well, -12 times -1 over the square root of 4, which looks like that is 6. Choice C. Good? For all you people that have already taken the AP test here. Yeah, you're all good. People at home, good? Anybody else, any other questions?
I guess briefly 30.
30. Sure. All right. So we are given a Maclaurin series, converges to f of x for all real numbers. G is the function defined by g of x equals e to the f of x. And we want to know the coefficient of x squared in the Maclaurin series for g. Okay, let's see. So f of x is 2 plus 3x plus x squared plus 1/3 x cubed and so on. If g is just e to the f of x, then this should be e squared plus, no, that's not right. Should be 2 oh, yeah, okay, so let me think about that for a second. The Maclaurin series converges f of the g is the function defined by g of x equals e to the f of x. Okay, so f of 0 is 2. Let's maybe solve that. F prime of 0 ought to be 3. F double prime of 0. So our coefficient here is 1, but this should be over a, normally this would be over a 2 factorial. So f double prime of 0 needs to equal 2 factorial. So f double prime of 0 needs to be 2. And if g is e to the f of x, then G double prime ought to be E to the f of x. Okay, well, actually, let's do this. G prime ought to be E to the f of x times f prime of x. And G double prime ought to be E to the f of x times f double prime of x plus, I should have put this further over. So G double prime ought to be E to the f of x times f double prime of x plus E to the f of x times f prime of x times another f prime of x if you take the derivative of G prime. And if we're going to evaluate that at x equals 0, this should be E to the f of 0, f double prime of 0, plus E to the f of 0, which is 2 again. F prime of 0 and another f prime of 0 ought to be 3 and another 3. So that ought to end up being 11 E squared is what G double prime of 0 is. And then we need to, since we're writing this out, this should be, if G double prime of 0 is 11 E squared, then the coefficient on the x squared term ought to be 11 E squared over 2 factorial, which ought to be D. Does that make sense? So you got to take the terms from here to find f of 0, f prime of 0, and f double prime of 0. And f double prime of 0 is 2 because this has to be 2 over 2 factorial to give us a 1x squared. Then you take your derivatives of g. G prime is e to the f times f prime, and g double prime is the derivative of that using the product rule. Plug in your zeros for everything to find g double prime of 0, and then divide by the 2 factorial. Good or no?
It makes sense. I just haven't done this before.
Yeah, that was a fun one, huh? Now you've done it.
That is true.
Other questions from anybody? No? Huh? 82. Sure. All right. So, is that all it gave us? Did I miss something? No, that's all it gave us. Okay. All right, so we have h is a continuous function of x. Which of the following could be a slope field for a differential equation dy dx equals h of x? So if h is a function of x, we could definitely tell that it could not be choice C because this wouldn't pass our vertical line test for it to be a function, right? Just based on how these solution curves would be drawn. So we could get rid of that one. If the function is going to be continuous, then the same thing would have to be true here, right? This one, that's not going to work out. And the same thing would have to be true here, whereas we get, for each different x value, we might have two different possibilities of y value. So that one's not going to work out. So this is the only one that could possibly work out, that it ends up being a continuous function of x. Does that make sense?
On the PDF you uploaded, the equal sign looks a lot like a minus sign, or the one that's in the Google Drive, I mean.
Does it?
Yeah. Actually, it looks exactly like a minus sign to me.
Really?
Yeah, I could share my screen if you're interested.
I don't know. I mean, I'm looking at the PDF. That's where I'm pulling these all from. Doesn't look like a minus sign to me, but.
Or maybe it's low quality because I just opened it in preview mode on the Google Drive.
Yeah, could be. That would explain why you might have had difficulty with that one. It's all right. I believe you. You don't need to show me. Other questions? It wasn't very good quality to begin with, so if you opened it in preview mode, it was probably even worse. Anybody else? Any other questions? All right, going once, going twice. Nobody. Okay. All right. We had a free response question, I think, that I'd asked you guys to do a while back. And I said we'd go over it today if we had time after these multiple choice. Does that sound right? Jenna says yes, even though I don't know why she'd be doing it. She's already taken the AP test, but which one was it? Was it an area volume one? Seems like it was like a whole week ago that I asked you to do that. I don't remember anymore. All right, well, let's run through it real quick anyway. So part A, write but don't evaluate an expression involving an integral that gives the perimeter of R. I feel like we did go through this. I think we did. I remember writing this out. I did. Did I?
I don't recall you going over it.
All right, that's fine. This value here is clearly 1, right? We're going up to 1. So our perimeter is going to start with 1 plus this distance. What's that distance? Should be k. What's this distance? E to the 2k. And then this distance should be what? The integral from 0 to k, square root of 1 plus, and then the derivative of e to the 2x. So f prime is 2e to the 2x squared dx. Good? Part A should have been pretty easy. Yeah, maybe it was just a similar one that I went through. I thought I'd remembered writing one out. They gave you 3 points for that. 1 point for correctly getting the derivative. 1 point for the correct integral. 1 point for everything together with all the other 3 pieces of it as well. Good?
Good.
All right. Part B. We take R and rotate it around the x-axis to form a solid, find the volume V of the solid in terms of K. So that ought to be pi times an integral from 0 to K of that radius squared. And what's your radius? Just e to the 2x. So what does that come out to be? That's e to the 4x before you integrate it. And when you integrate e to the 4x, what do you get? Should end up with pi still there. Should have a 1/4 e to the 4x from 0 to k. So that would be pi over 4 e to the 4k minus pi over 4. And that was worth 4 points. Wow, 4 points. 1 point for the correct integrand setup, 1 point for the right limits, 1 point for the correct antiderivative, 1 point for the correct final answer. Good? Yeah. All right, and then part D said the volume, which we found in part B, changes as K changes, obviously. If dk dt is a third, determine dv dt. So we've got volume equals pi over 4 e to the 4k minus pi over 4. And we have dk dt as 1/3 when k is 2. When k is 2. No, when k is a half. And then we want to find dv dt, so we'll take that derivative. dv dt equals, what's the derivative of pi over 4 e to the 4k? Should be pi e to the 4k dk dt. And then the minus pi over 4 should go away. And dv dt should be pi times e to the 4 times 1/2, so pi e squared times 1/3, or pi e squared over 3. And they gave you 2 points for that, 1 for properly taking that derivative, and 1 for the answer. Any questions on that? Good with that? Not good with that? All right. What else do you guys want to work through? More free response? I don't really have any more multiple choice to give you, so if I did, I would, but I don't.
Do you know anything about the digital FRQ structure? Because on the practice tests, online practice tests anyways, it seems to be just a lot of explaining how to do a question rather than actually doing this kind of stuff.
Yeah.
I mean, like in part C.
That's basically what it's going to be. They're going to have you explain what to do. They haven't given me any additional information to what they gave you. In fact, they didn't even give me any practice, like explain how it works questions. All they said was, if you can do all the old FRQs, you'll be able to explain your process for the FRQs on the digital exam. So, I mean, for example, if you were doing this one, you would say, you know, let's say if you were doing part C, you would say something like, well, we had the volume formula as whatever it was. You have to take the derivative with respect to t of both sides of that using the chain rule, and then you would plug in the value. And that would be a good enough response, I think, for them. But yeah, they didn't give, and in fact, they specifically said we will not be giving any, particular type. At least that's what they said. And who knows what they might do in the next week. they said we will not be giving any specific type FRQs. If you can do all of the old FRQs, you are good. That's what they told us basically. So I don't know. I mean, I don't know if that helps, but yeah, just writing out explanations in words is good.
Okay.
If you're doing part B, you'd want to say something like, because this region is pushed up against the x-axis and you're revolving it around the x-axis, the cross sections are circular, so we can use the disk method. So it's pi times the area, which is, or pi times the radius squared, which is the area of each of those circles, and then you integrate it. You just want to write something like that out. Does that help at all? I don't know if that helps at all. So.
I guess it's easier in some regards because like the way we've approached it is sort of like more of an emphasis on knowing the equation, how to do it, rather than why the disk method actually works. So couldn't I've just said that we can use the disk method here because of, so and so the conditions are correct.
Well, I mean, the disk method works because what do you get? You get all these circular cross sections, right? And if I take each of these circular cross sections and find their area, or find their volume, which is the area of the face, pi r squared times the thickness of them, that's your dx. If I sum together all these tiny little volumes from 0 to k, that's the whole basic idea of how we set up that method, is we're summing together all these tiny little volumes from 0 to k to get one big volume. These infinitesimally thin disks, or infinitesimally thin washers, or whatever what have you.
Okay. And I guess there hasn't been much FRQ in the past where it's like explain what.
No, they've not. The only ones they had for that were they had some last year, but I mean they didn't release them. They just had some, on the test. That's the only time they've ever had, but they didn't release last year's questions. So.
Okay.
Yeah.
Well, I guess the main thing is just to understand what you have to do. It doesn't really matter if you make small mistakes on the algebra now, I guess.
Yeah.
Because there is no algebra.
There might be a little bit where you got to type something in, but I don't think there's going to be more than, they're not going to make it, I can't imagine they're going to make you type in something like this integral, You would have to explain, well, first find the length from y equals 0 to y equals 1 on the y-axis, that's 1. First, then find the length from 0 to k on the x-axis, then find the height of the function at k to find the third distance of the linear piece. Then you'd use the arc length formula, and you'd explain what it is. And, if they actually explain why that works, it's the same concept. It's just the distance formula shrunken down to tiny, tiny, tiny little pieces, just like these are, areas or volumes of these tiny disks shrunken down that you're summing together. That's what the arc length formula is. It's a bunch of little tiny line segments that you're summing together. Same with if you're doing any integral, basically. You're summing together all those little rectangles to find the area. Same concept.
Okay.
I can try and pull up something that might, I don't know, I could try and find one where there's a little more explanation in it required, but let's say most of them don't have you do a bunch of explanation stuff. To be in here. Trying to find a good one where there's lots of explanation, but there aren't really. I mean, there really aren't that many is the problem. But we could just pick a couple. We could just pick a couple from the miscellaneous ones and like sort of go through. You know, I'll let you guys work on and talk about what you might have to write if it was an FRQ on this year's digital test. Maybe that would be helpful.
Yeah, that's what I thought too.
See here. I know this one. This one's got some BC content on it, so let's do this one. Give me 1 second here. This is like page 15 in the miscellaneous ones, but I'll put it in here too. I don't believe we've done this one yet. So I'll give you guys a few minutes to try and work through it, and then we can talk about what you might, you know, if they gave you something similar to this, what you might need to write. Because for some of it, I mean, you probably can just put an answer and still think. I don't know, it's hard to tell. Yeah, I'll give you guys about, I don't know, maybe 12 minutes or so to look through this one. I'm not sure how they would ask you really to explain that. I mean, you can say that you could say that the average value of a continuous function basically just means that you are looking for the y value at which the picture we always draw is if you have some function, there's some y value within there. This is the average, where the area underneath the full curve is equal to the area of the rectangle that is made between, in this case, 1 and 4, right? And so you could write out something to that effect. But then, you know, I don't think they'd ask you to explain where the average value theorem comes from. So I think you'd be okay there. Then let's say we were to take this and revolve it around the x-axis. So we would know that then same thing, that since this is 1 over root x is fully pushed up against the x-axis, the cross sections are disks or circular cross sections that have an area of pi times the radius squared, and your radius is just 1 over root x. And so that would be your volume. If this was on the AP test, you could just explain that these are circular cross sections that have a thickness of dx and that they have an area of pi times the radius squared. And so you sum together using an integral all of those little disks that are infinitesimally thin from 1 to 4. Does that make sense? That's what I would say if I was writing that one out.
Yeah, it makes sense.
There was our bell. So people are leaving. So we'll finish talking about the rest of C and D tomorrow, and we'll try and do some more free response. I'll see if I can find some more multiple choice somewhere. I'm pretty sure I've posted everything that I have in terms of multiple choice for you guys already.